we're going to give a quick sketch. All right. So you're going to give me a little sketch. Now, when you graph this, and again, we're not using clip marks. Here's a pass I would put right up here for anybody that needs to use the bathroom until they further say I can't use it. So now, your sketch, pay attention to like where it's crossing your axes. You don't want to sketch it up here or way down here. It's kind of going through the zero. Pretend mine's going through the zero. Really, this is so bad today. It was so bad yesterday. I know I reset it yesterday. Yeah, because it's so off. But yesterday, every time I reset it, it was still off. It's just, I think this thing down here has a malfunction because I've had this happen before, and they had to replace it. And they're not very good about replacing these. So hopefully I can get this to work. It works better from this end, but I might have to bring my computer in. So let's try this again. So it's coming through the zero and going like this, right? Now let's talk about this for a second. We're going to describe this. This 2 up here tells me I should have 2 roots. 2 roots. They can be real or they can be imaginary. Real, they cross the x-axis. Imaginary, they don't cross the x-axis, and that's when we'll use the I. Right now, we're going to work on the real ones, and then we'll throw an imaginary one in there soon. So this tells me I have 2. If I take this and I subtract 1, that tells me I have 1 turn. And it turns once. A good way to start describing. When you have an even exponent, the ends behave the same way. When you have a negative in front of your coefficient, if it's a negative, then they open down. So already from this, I can tell I have a parabola, it's opening down, I have 2 roots, 1 turn. So I can start telling things already. I can start describing things already. This, when I pass through the roots, these are my intercepts. This is when y is equal to 0. This gives me my x-intercept. In this case, my roots of my equation. How would I get that algebraically? Allie. Oh, I thought you were raising your hand.
Oh, you could just make y 0.
Yeah, and then what would I have to do to that? Yeah, you would factor, right? You would set it equal to 0, set y equal to 0. This is one of your intercepts. So we're just going to set this equal to 0, and we're going to factor it. So if you factored out an x, or you factored out a negative x, whichever way you feel, then set them equal to 0. So x would be equal to 0, and x would be equal to 1. Negative x would be negative 1, so x would be 1. This is a good way for me to find these 2 points. God bless you. This is a perfect way for me to find this. So I know I'm opening down. So if I had to sketch this without my calculator, and I looked at my intercepts, my x-intercept, and we found these to be x is 0 and x is 1. Then we looked at your y-intercept when x is equal to 0. If I plug a 0 into those, I get negative 0 squared plus 0, so I get 0. So I have 2 points already, 0, 0, and 1, 0. So if I was to sketch this without my calculator, I would say I have 2 points, 0, 0, 1, 0. My parabola is opening down, so the ends of these have to come down. So where does this have to go? It has to turn a little bit right here, right? It just has to turn. How high up? I don't know, but I know that would be my sketch. So I want you to start thinking in terms of where are my intercepts? Which way are these opening? How many roots do I have? Where are my ends going? So that we can eventually sketch this without our calculator. We're going to use our calculator to find max and mins and do some other little things. But we're going to try to visualize this as best we can. Okay? What happens in a sketch too is this. If I sketch this, I say, oh, I know I have a parabola, it opens down. I'm just going to wing my sketch. I'm not going to place it where I need to place it. So your intercepts are really important. Just like we do your domain, we'll do your XY intercepts on everything. I'll bug you with XY intercepts all the time. So now we get this far, let's describe this. What's my domain? All real numbers. Can we tell our range just from looking at that yet? What do we need to know? The max. Good, the turning point, the max. I'm going to label this A. Okay. Is this a max or a min? A max. Is it an absolute or a relative? Absolute. It is absolutely the maximum point on this graph. So let's find it. So in your calculator, do you know how to find a max? Okay, so let's work together on this. Okay, so let's graph this stuff. My graph is a little off, but it's probably better because you're so close to the axis here. So if you can't see it when you do a regular graph, if you have trouble seeing where it's peaking, remember, if you want to get more definition in here, change your Y. Go to your graph, your window, and change your Y. Just make your Y go from like -3 to +3. It spreads it out a little bit more. And you get a little bit of a better definition. You can still find your max when you do a max or a min. You can still find that. So now, to find your max, second calc, maximum. There's two ways to do this. I want you to isolate where your maximum is, and you can have more than one max. So you have two ways to do this. You can do this off of your number line. You could say set the x like from -3 to +3, because I can see where my max is falling somewhere between there. Or you can use the cursor. Make the cursor go to the left, hit enter, make the cursor go to the right, hit enter, and then guess. You're always going to hit something 3 times. So if I'm going to use my left bound, my right bound, I could say -3 to +3. It's looking right in here. And I say guess. And it gives me my, oh, I must have hit my minimum somehow. Because my calculator is a little crazy. Okay, so now, -3 to +3. And again, I'm looking right in here, and it gives me my max. So on your calculator, be careful of these guys. I'm sure you remember this from last year. Sometimes they come out with like 1.9999999, and that's really 2 or 2.00001. They don't get it, they actually get a lot more defined than we do. So this is your 1/2. So this is going to be at 1/2 and 1/4. If you want to leave it as 0.5, 0.25, absolutely. A rule of thumb for all of precalc is when you round 3 decimals. So we're always going to round to 3 decimals if we need to. Now another way to do this is with your cursor. If you're more comfortable doing this with your cursor, do it with your cursor. Come down here and bring your cursor to the left and hit enter. Bring your cursor to the right and hit enter. And then guess, the guess. It gives you the same thing. Now see here, it's doing the opposite way. It's saying 0.499999, that is 0.5. Or 1/2. Everybody can find the max using it either way, whatever way you're comfortable. I find If it's clear to me where it is and I could set the limit myself, I set it. If it's not clear and it's too close to something else, because we'll do some that have multiple maxes, then just go to the left, go to the right. It makes life a little easier. So now, once we have that max, can you now find your range? So what is your range? To 0.25. Hard bracket or soft bracket? Hard bracket. Good. So we know our absolute max. So we'll label this A. I tend to like to label things. We'll label this B and C. Because what happens is, you want to tell me where they are. Don't put it all on your graph, because you end up with so many things on your graph you can't see what you're doing anymore. So we'll label these guys B and C. God bless you. God bless. Now, increasing is like the roller coaster. You always go from left to right. You're looking at the value of y to be increasing or decreasing. And you're telling me where it's increasing or decreasing by your x interval. So I start here, I'm coming up like this. Am I increasing or decreasing? Increasing, and then I stop right here, right? And I start to decrease. So from negative infinity, I do all these x's. From negative infinity, I stop when this x is what? 0.5. So I'm increasing from negative infinity to 0.5. Increasing and decreasing always have a soft bracket. Because sometimes they share the same point and they don't really stop at this point. Then from this point on, my y value is decreasing as my x increases, right? So if I'm telling somebody where the y is going, I'm going to say, well, when my x is 0.5 to infinity, my y is decreasing. So 0.5 to infinity, I am decreasing. After your increasing, decreasing is done, go back and make sure that you covered whatever your domain was. If you were missing a piece, because we're going to do some that turn a little bit. So if you were missing a piece and it doesn't fill your domain, it means you just missed something. So go back and take a look at it. Sometimes when we do some of these, they go like this. They turn a little bit more, and then we forget something in between. So make sure it covers your whole domain. So this is how we're describing. We can describe this graph, and we're going to say, I don't want to move this, but the last one is odd or even. So we say it's even because why? So eyeball this first, Lily. Do you see symmetry?
Yeah. Oh, yeah.
Symmetry where? In the middle. Symmetry over this guy, right? So it is symmetry. But to be even, it has to be a reflection over the y-axis. So I have to have the same, I have to use my rule of just negate the x and have the same y. So this is not an even. Odd would tell me through the origin. If they're both coming down, they're not going to be odd. But algebraically, we have to try algebraically. So we're going to take this and we're going to put a negative x in. Now be careful because you're putting the negative x in, but you're keeping the negative sign because that's there. So this still becomes x squared, so it becomes negative x squared minus x. Is this the same as what we started with? No. So let me factor out a negative 1. So this becomes a positive, this becomes a positive. Is this piece the same as what we started with? No. This piece right in here. I had to factor out my negative 1. So therefore, that's not an odd either. So this guy is a neither. You're going to plug in the negative x. You're going to take a look at it. Let's do it up here. Plug in the negative x. This negative stays. There's your negative x. This, an easy way to do this is just put parentheses around your x. plug in the negative x. This becomes negative x squared minus x. So we said that's not the same. So it's not even. To be odd, every sign has to be opposite. So are they all opposites? Mm-mm. If you struggle with that, take out a negative 1. This becomes a positive. This becomes a positive. Is this my original? No. So it's not odd. Odd says they all have to be the opposite sign.
Why do we have x squared plus x squared?
Oh. Because I'm talking and writing at the same time. You got to catch me on those. So if this is exactly the same now with the negative 1 in front, then it would be odd. Or eyeball it and just say, is it everything the opposite sign? I would have to see x squared minus x for me to be an odd. An odd has symmetry through the origin. The evens, most of the time, are not going to work because they're not going to work because your symmetry through the origin is here. It would have to be here and here, here and here. And they're both going in the same direction. So they're not going to happen. Don't forget to solve these algebraically. The intercepts and the odd and even, we're going to solve algebraically. I know you can confirm it on your graph. You can absolutely go to your graph. You can find the roots in your graph because they're sitting there. But I want those algebraically. You can see those on our table right here. Confirm it that way. But solve those two pieces algebraically. Again, the domain we can spot, the range we're going to have to look for a max or a min, and then we'll give your increasing, decreasing as well. Good? Questions? It's a little different. There's no tick marks here. We're sketching. Kind of goes against your rules of Algebra 2. Algebra 2 said, show me all your points. I need to see your points. Here we're doing sketching. Hi. Oh, come on in. Come on in. This is my pre-calc honors class.
Okay, alright.
Want to talk to them?
Yes, please.
Mm-hmm.
Hi guys, how are you doing? Good, awesome, great energy. My name is Lisa Mahajer. I'm one of the assistant directors in recruitment at Mercy College. I'm here to present to you about articulation. Are any of you familiar with this program? What grade are you?
Juniors. They're juniors.
Juniors?
Yeah.
Okay, awesome. So, does anyone know anything about Mercy College? No, we are a 4-year private institution located in Dobbs Ferry, New York. It's about an hour and a half and 2 hours away from here. We're here today to present to you the high school articulation program. Your guidance counselors and your teachers worked hard to submit this application into Mercy College, so you guys can take this course and receive college credit for it. Sounds interesting? Yeah? Okay. So you'd be able to stay in this classroom. You never have to go to Mercy College. If you sign up for the program, you'd be able to receive 3 credits for it for the fall semester. Excuse me. If you receive these 3 credits for it, you'd be able to transfer it into Mercy College, or you'd be able to look into the college that you're attending and be able to transfer it there. So it's a pretty cool process because you'd be getting your grade for high school, and then you'd also be getting a college class grade. We do offer it to students at a really discounted rate. Typically, these courses would run to about $2,000+ in college, but we offer it for $50 a credit, so it'd be $150. Is this something you guys are interested in doing? Yeah? Okay, so I do have registration forms for you. You would go on our website and then you would just follow these instructions and you'd be able to register for the course. You would also pay with a debit card, credit card, or check. So if you don't have those options, you can ask your parents, or you can also go to your local Walgreens or CVS and get a Visa card from there and then purchase the credit. Sound clear? Yep. Okay, so the deadline is October 15th. We do urge students to go home and talk to their parents about it if it's something that you did want to do. If you do, give us a call October 16th and say, hey, I forgot or something, could you extend the deadline? The answer would be no, and we don't want to be that person. So please do go home and talk to your parents about it. I will be giving out these forms that have information. If you do have any questions, feel free to give me a call or shoot me an email. Sounds good? Yep, okay. My colleague and I are actually here throughout the entire day, so you may see us more than once in a few classes. So, bear with us. Yeah, Dominic here. I can let him know you said hello.
Yeah, he always comes into my classes. I see him every year. I thought he was not doing this part anymore.
Oh, well, he's a director now,
So he still comes to this classes.
because this is such a big school for us, it's easier to get it, for two people.
They're juniors, so I don't think you had AP classes before this year, right? This one you had one last year? Oh, thank you so much. Thank you.
Yeah, so the way this works is it's only available to juniors and seniors, so it's an awesome opportunity for you guys. You're able to take up to 24 credits, so essentially what that would do for you is you would come into college as a sophomore if you take up to 24 credits. You have the opportunity to take less courses in college, and then you also have the opportunity to complete internships while not being overloaded with work, as well as study abroad. So definitely do think about it. Go home and talk to your parents. Okay?
Thank you.
Thank you.
Thank you.
A little bit more gut, a little better than the other one. There is no AP test in this course. This course doesn't have AP. The calcs do, but not the precalch. So you take our finals, which is a Mercy College final, well, equivalent of a Mercy College final, and you can buy your credits, and you don't have to. All right, so let's just finish this next one, and then you can have a chance to talk about whatever you guys need to talk about. So do you have this one up there? All right. Now, this one is going to tell me I have 3 roots that are going to cross. In this case, they're going to cross the x-axis because we're real roots right now. 3 minus 1 is 2. I have 2 terms. 2 minus 1 is 1 inflection point. And we'll talk about an inflection point. I have 3 roots. It's going to turn twice, and I have an inflection point. Okay. All right. We take this one, we subtract 1. So 3 roots, minus 1, 2 turns, minus 1, 1 inflection point. And we'll briefly talk about an inflection, but then I'll throw it in at a different time. But I like to introduce it now. So, if we were going to sketch this, just sketch this, the first thing we would do is find your intercepts. Now, this one, you can't find your intercepts algebraically. You're going to need your graph for this, because I can't factor out an x. If I plugged an x in the last one, then yeah, I could factor out an x. So, this one we're going to do off your calculator. So we're going to graph this guy. I purposely took the x out because there are some times where you can't factor. So let's throw this in your calculator. It's still going to behave the same way. Because your coefficient is positive and it's an odd, the left side is going to go down and the right side is going to come up. It's going to have to pass through the x-axis and give me 2 turns. It's going to come up like this, cross, and go like this. So already we can kind of see which way it's going to go. It has to come from down, cross over, and go back up. So here's my turn, my 3 roots. So somehow it's going to look like that. So we're going to plug this in. And I'm sure you can get it in there faster than I can get it in there. So much easier to put here. Okay, so let's graph this guy. I have it again, and my y is from -3 to +3, but it's good that way. So do you see we described it? It does exactly this. The left side goes down, the right side goes up. It has two turns, and it crosses the x-axis 3 times. Okay, so as close as you can to that, make a sketch. All you're doing is this for me. This is a sketch. This is probably a little further down. Maybe that's not a little bit up, but I only am at the 3 because I changed my y-axis. We're going to have a point here we have to talk about, a point here we have to talk about, and these guys. Now go to your table and see if you can spot where your zeros are. Where I'm crossing the x-axis. So do you see 1 point, 1, 0. There's my point 1, 0. Do we have any others? No. No. I see a cross, but I don't see where it is. And do I have can you spot a y-intercept in here? What's your y-intercept? 0, 2. Okay, I got this guy now. And is that also my maximum? I'm going to find that out in a second. It's the only place it crosses my y-axis, so I'm going to verify that using my maximum. So let's check your maximum while we're here. Check your max. Should be exactly 0, 2. It's only crossing the y-axis once, but we're going to check it anyway. It's good practice. So again, where this is kind of tight right in here, see it's kind of tight in there, just move your cursor. Cursor to the left, cursor to the right. It's got to look right in between those arrows. And there's my max. That with the e to the -6, that means move your decimal point 6 places to the left. It's just a scientific notation number. That's a 0. Your calculator does weird things. So there's my point 0.02. That's my max. Let's find your min while we're here. If it's okay with you, I'm going to do it from here. So again, this is your min down here, point B. So I'm just going to move my little bug guy here to the left. Do it with me, guys, so you understand. Go to the right. And see the little arrows? That means I'm looking within those arrows to find that minimum value. I guess, and there's my minimum value. So what would you say your minimum value is? 2, -2. Don't let the calculator throw you off. So we only have to find 2 more things. 2 more roots to this. Does anybody remember how to find the roots? We're using a calc. Zeros. Good. Come down to the zeros. The zeros means your y is 0. They call it the roots, the zeros, the solution. There's a number of ways to call that. So now, you're looking for this. Let's look for the left one. We have the one that's 1, 0, so we don't have to find that. Go to the left of the one you want. Then go to the right of it. All you got to do is go right up there. You're right to the right of it. And then guess. Now, we have an irrational number here. So we take that decimal and we do 3 decimals. Three decimals in pre-calc. Excuse me. Now see if you can find the one to the way to the right. zeros again. It's easier when they're this close together just to move the cursor. Isolate that guy on the right. Just go right above it. God bless you. And we know it has to be greater than 2, so this makes sense. 2.732. Everybody found those okay? Good? Okay. So we've got our max, we've got our mins, we've got our zeros. I'm also going to give you the factors to this so that we can do this algebraically in a minute. So let's talk domain for right now. What's the domain for this guy? Do you see any errors on your table? No. So what would our domain be? Our real numbers. Because this is an odd function, or an odd exponent rather, an odd exponent, your domain is all real numbers, and so is your range. So your range is all real numbers. Do we have an absolute maximum? What do we have? A relative maximum. We have a relative maximum. And we labeled that point A, and that point was 0, 2. Do we have anything else? A maximum, and we have a relative minimum. So we have a relative minimum. And that point would be B, which would be 2, negative 2. Good. Let's hit your increasing and decreasing. Your increasing starts way at the left, because you're reading left to right. What is y doing when I start coming up like this? Increasing. So where am I increasing from? To where? 0. The x value. See, here's the difference. If you give the y value, then you gave the y value of 2. You don't really know technically where your x is going. So it could be straight up here, can it? If my y value is 2, can I be straight up here? It doesn't really tell me that I'm going this way. So it just tells me, whoops, you're going up like this to 2. So you want to chart the x values, the x intervals, as y is increasing and decreasing. What is it doing from here, from point A to point B? Decreasing. So give me the x values where your graph is decreasing. To 2. Then, all of a sudden, I make a turn, and what am I doing now? Increasing. So we put a little u here, 2 to infinity. We got it. Not so bad, right? Now, I'm going to factor this guy. I'm going to give you the factors of it. Our y-intercept is easy to find. I would go back to the original all the time for the y. Because what are you plugging in for? To find your y-intercept. A 0 for what? X, right? So if you plug in x of 0 and x of 0, if you cover this up, what's your y-intercept? 0, 2, 0, 2. So 0, 2. So all you have to do is show me a little work. You just have to say this. 0 cubed minus 3 times 0 squared plus 2. There's my y of 2. There's my y-intercept. Now the x-intercept are your factors. So I gave you the factors. So we're going to set your y equal to 0, and we're going to factor these guys. I'm not going to make you do the whole thing on. I just want to walk this through with you. So now, can you give me factors for x squared minus 2x minus 2? Can we factor that? No. All right, Nicolette, we can't. So what would we use when we can't factor? Quadratic formula. We would have to throw that into the quadratic formula, which I'm not going to make you do right now, but that is a situation that exists, right? So in this case, I'll give you the roots. It's 1 plus or minus radical 3. Okay, so if you gave me algebraically, this is what I would expect. And when you have two roots like that, if you want to leave it like this, comma 0, that is fine, because you can't go any better than that. You can't get any further down than that. Okay? So we sketched and defined everything. Are we good? It's a little different than what you're used to, right? You did a lot of, did you do domains? Did you do intercepts? Increasing, decreasing? We're just kind of throwing it all together at you.